Now, grade 12s, I'm going to introduce you to another term that we use. And again, it's just about understanding the language. It's not that we're doing anything different or new. And that's the term quantiles and percentiles. That's a way that we can convey that we're looking for a probability. Okay, so for example, and it's always about a value below the value. So for example, to determine the 0.7 quantile of a standard normal distribution, we're looking for A such that the probability of Z being less than A is equal to 0.7. And that could also have been asked in a way of saying, find the 70th percentile. So when you're looking at quantiles or percentiles, you're actually looking for the area under the curve. And they're giving you the area under the curve, and you're looking for the A value where the probability of Z being less than A is equal to that quantile or percentile. And we can use that information to work backwards to find different unknowns. So let's have a look at this one. For the normally distributed variable x, the 0.15 quantile is 1.9927 and the mean is 2.7. Determine the standard deviation. Alright, so I think the main way to start these is to draw yourself a little distribution, because that helps you to understand what is being asked. Okay, so they've said the 0.15 quantile is 1.9927. So 0.15 is a really small area. So they've given you 0.15. So it's that little area there, because it's the value of the area under the curve less than or equal to a value. And they've told you it's 1.9227. They've also told you that you've got a mean of 2.7. So that kind of makes sense. 1.9 is less than 2.7. So where I've drawn my values makes sense. And we're looking for the standard deviation. So they've given me that x is normal in mu and sigma squared. And we know that x has got a mu of 2.7, but we don't know what our sigma is. Oh dear. Now, your calculator can't go directly and tell you what that is, but we can use our standard normal distribution, which is our way to compare distributions, to help us. Okay, so using our inverse normal on our graphics calculator, okay, is this a left tail or right tail? Well, we know it's a left tail, so our tail is left. Okay. We know that our area is 0.15. Now we're going to use our standard normal distribution. So sigma is going to be 1 and mu is 0. And what we get then is a z value. Okay, so we have that z is equal to a value. Let's have a quick look at what our z value is. Oh goodness. Our z value is going to be, let's go look here, left tail. Our area is 0.15 and our standard deviation is 1 and our mean is 0, so our z value is negative 1.0364. Now, we've got an x value. X, we said, was 1.9227. We've got a z value, and we know that we can relate our x value and our z value to each other using mu and sigma, and that then helps us to find our unknown value. So z is x minus mu over sigma, and I've been given that my x value was 1.9227, my z value was negative 1.0364, my mu was 2.7, and I don't know what my sigma is. So I can just pop all those values in. So negative 1.0364 is equal to 1.9227 minus 2.7 over sigma, and my standard deviation is 0.75. Alright, let's have a look at the next one. It says x is normally distributed so that the 63rd percentile is 15.896 and the standard deviation is 2.7. Find the mean. Alright, so very similarly, we know that x is approximated by a normal in mu and sigma squared, and they've given me the standard deviation, but they haven't given me the mean. All right, so let's draw ourselves a little distribution because it helps us to understand where we're working with these things. It gives a good picture for our teacher to see that we understand what we're doing and sets us along the way. So we don't know what our mean is, but what we do know is that the 63rd percentile, so 63% of the area under the curve, falls below 15.896. So we know 63% is more than 50. And so I'm expecting a value above my mean, because half of my data falls below my mean, half above. Okay, and I'm expecting that that area underneath that curve is 0.63. Okay, so now I've got enough of a picture to be able to use my calculator because I've got a left tail, and I'm going to use my standard normal distribution. So using inverse normal on your graphics calculator, we know that our tail is left, our area is 0.63, our standard deviation is 1, and our mean is 0. And that gives us a z value of, let's put it into our calculator. So we've got a left tail, our area is 0.63, and that's 0.3319. Okay, so z is 0.3319. Now again, we want to be able to relate our z value and our x value using our standard normal formula. So we're going to have z is x minus mu over sigma. We have that z is 0.3319. We know that our x value is 15.896. They told us that our standard deviation is 0.7, and we don't know what our mean is. So we can put all those values in. 0.3319 is 15.896 minus mu over 2.7, and our mean for this distribution is 15, which makes sense because our 15.896 was above our mean.